Welcome to your second video lesson involving electrical interactions. In this video, we're going to continue off our first video, except this time we're looking at an electric charge that is moving perpendicular to electric field lines that's created by two parallel plates. So once again, this electric charge is going to have an initial velocity that is parallel to my parallel plates and perpendicular to my electric field lines. So let's take a look at my first example. First, let's copy down this diagram the best you can. So we have a negative charged plate on top, and we have a positive charged plate on the bottom, and we have an electron traveling through these two charged plates. So the electron experiences here a downward acceleration because it's going to repel from the negative and attract to the positive at an acceleration of 2.0 times 10 to the 17 meters per second squared. Determine the time taken for the electron to travel 0.1 meters to the positive plates. So now I also know when my electron enters the field, the distance between the electron and the positive plate will be 0.01 meters. Now, just like my Thelma and Louise questions from Physics 20, so that means we're going to be looking at my y vectors to determine time. My y vector for velocity is going to be 0 because my initial y for the velocity is 0, and we have an acceleration of 2 times 10 to the 17 meters per second. So we're going to use the equation of distance is equal to my initial velocity multiplied by time plus 1/2 of the acceleration multiplied by my change in time squared. Now we want to isolate for time for it to take to fall to the positive plate. And we know the initial velocity is 0 in the y direction, so we're going to end up getting my distance is just equal to 1/2 multiplied by the acceleration multiplied by the time squared. Now we're going to rearrange for time to get the square root of 2 multiplied by my change in distance divided by my acceleration. Now we're going to plug in my variables that we know. So we know my distance is 0.01 meters, and we know my acceleration is going to be 2 times 10 to the 17 meters per second squared. This will end up giving me a total of 3.16 times 10 to the negative 10 seconds. So once again, this is very similar to how we did our Thelma and Louise questions. Now once I find this here, and I know my time, it's easy for me to find out, if I wanted to know, how far the electron would travel before it hits the plate. So what would be my x? So now that I know my time is the one thing that is transferable between x and y. So I would just go distance is equal to velocity times time to figure out the distance of where the electron would hit my plate. But for this question, we do not quite know my velocity. But in my next question that I have for you guys to try by yourselves, we will know that velocity. So you should be able to figure out what is the distance the charged particle will travel perpendicular to my electric field lines. So here is a question for you to try to figure out. I want you to copy down this question, or copy on this diagram, and then copy on this question and try and answer this one here by yourself. For our last question, we're going to attempt a question where we do not know what is the acceleration of this electron due to the force, but instead we know what is the strength of the electric field. Now using the strength of the electric field, this could help us figure out my electrostatic force between the two parallel charged plates. So first thing you have to do is sketch the field lines between the parallel plates. So my field lines are always going to go from a positive to a negative. So they're just going to go like this here. These are going to be my field lines. Now that I sketched my field lines, we want to determine the force due to the electric field on the electron. So we know force is equal to the charge times the electric field. So we have 1.6 times 10 to the negative 19 coulombs, because remember it's an electron, multiplied by 225 newtons per volt. Altogether, we're going to get a force of 3.6 times 10 to the negative 17 newtons. Part C says, calculate the acceleration of the electron. So now we know force is equal to mass times acceleration as well, so I could use that to help me calculate the acceleration of the electron. So my electrostatic force is equal to mass of electron times its acceleration. Then we're going to isolate for A, so I'm just going to go my force divided by my mass is going to be equal to my acceleration, which is going to be 3.95 times 10 to the 13 meters per second squared. Lastly, if the electron falls a vertical distance of 3.4 times 10 to the 4 meters towards the positive plate, how far horizontally did the electron travel? So first thing we must do here is find my time. So in order to find my time, I first got to look at my distance in the y. We know my Vy, my initial velocity, is 0 because it's not falling before it enters the electric field. So I could use my distance in the y is equal to 1/2 times my acceleration multiplied by my time squared. That's going to give me 3.4 times 10 to the negative 4 meters, which we were given up there, is equal to half of my acceleration, which is 3.95 times 10 to the 13 meters per second squared multiplied by my time squared. Now to isolate for time, all I have to do is take my distance, multiply it by 2, and then divide by my acceleration here, and then square root all of that, which will end up giving me 4.14 times 10 to the negative 9 seconds. Now that I know my time, I could use that to find my distance in my x. Since time is the one variable that is transferable between my x vectors and my y vectors. So here I know my distance is equal to velocity times time because there is no acceleration in the x. So I just use my velocity from above, which is 3.2 times 10 to the 6 meters per second multiplied by my time of 4.14 times 10 to the negative 19 seconds to give me a final answer of 0.013 meters, of which the electron will have traveled. So that is the end of your lesson on electrical interaction.